In this video, we are looking at rate of change of functions. I've picked out two different problems that actually can relate to one another. The first problem is pretty quick to do on paper. I didn't really show the work for plugging in the 5 and the -2 to the function, but that is something that I would be really fine with you doing on a calculator. I think the main thing is just to look at the overall kind of structure of that expression as we simplify it down, because it will help you to understand the difference quotient better. Now we're going to start with using Desmos just to do this first one, which is something I highly recommend. And in the second half of the video, I'm going to do something much more advanced, which is not something I recommend that you do, but if you just watch and follow along, it might help you to understand what you're looking at. So let's start with the part that I think would be most helpful for you to do. And that is in part A, simplifying and evaluating this in Desmos. So if you go to desmos.com, it's going to look like this. Just click Graphing Calculator. I do recommend logging in, and then you can actually save your graphs, and you have, for me, a long list of graphs that you can come back to later. So I'm just going to call this one, let's see, I'll click Save. I'll call this one Rate of Change Exercise. First thing I'm going to do is define the function by just typing it in the same way you might type it into your homework to answer a question. So you'll have to use Shift-6 on the keyboard to type an exponent, or you can use this keyboard and there's some options there. So my function was 2x squared minus 4x. I'm seeing it there. I'm able to trace it and see some points. Specifically, I had the interval from -2 to 5. So I'm going to put points on the graph to visualize that. I've got -2 for x and then f of -2 for y. This is exactly what a function does, is it finds the y value of the coordinate. So then I can do 5 and f of 5. You could evaluate those without creating a point. That would be easy to do as well, to get the -16, or sorry, to get the 16 and the 30 that I have there. But I like to even visualize it. So I'm going to have to kind of zoom out, scroll back, put the label on both of those points. I've got the 2 points there, and then I can go even a step further and type out this whole quotient the way it's written. I've got the numerator there, highlight it, hit the slash or division sign. Division sign's there. Slash on the keyboard will do the same thing. And now I've got, forgot my negative, I've got my simplified difference quotient right there, and that matches my work on paper. So that's a quick way to do it. Like I said, I want you to kind of understand how the structure looks so we can see it's just change in y, 14, divided by change in x, 7, to get the 2. Now to look at it in a more advanced way, I'm going to turn off all those labels and things and go to this second problem. So this second problem, there's not really a nice easy way where you can spit out the final answer in Desmos unless you're kind of just having a computer solve the problem for you. And that's not really the goal. The goal is to practice the algebra. So it is kind of a lengthy process, but please do work that out step by step. So plug in x plus h in for the x values. You've got that there and there. You've got to multiply the product of the binomials since it's the second power to get a trinomial there. And then you plug it back into the 2 and -4 coefficients, distribute those, and you've got your first part of the numerator. Then we need to subtract off the original function. So I've got that first part of the numerator, subtracting off original function, distributing through those negatives, and then canceling the 4 terms that have the same but opposite coefficients. And then lastly, take that's your numerator, divide each by h separately, you get your final answer. So that's the final answer. It's dependent on x and h. which means we can't just say, this is a slope of 2. It is telling us the slope, but it's telling us the slope for basically what's an initial point x and then a point that's h units away. So if you kind of look, the denominator is h. We're really saying the points are h apart, and it's sort of like x is our original point, and then we shift over by h. The easiest way we'll be able to do that in Desmos is by using a value of a instead of x. And that's just because it's going to try to graph it if we use an x. So I'm typing out that same difference quotient, just using an a instead of x. I'm going to highlight it, divide by h, and then I'll add sliders for those. So a is going to be my initial value of x. So I'll just go ahead and set that down to -2 to match the problem there. And then h, we like to have it always go to the right, so we like h to be a positive value, and that one can kind of depend. Now, we know that our denominator is 7, 5 minus -2, so that will actually be our h value if you want to just start it off right there. Okay, so f of, I did make a mistake there. That should be an a, okay? So basically, kind of modeling this, f of h. So I just changed the x to an a there. All right, so now I can see that slope of 2, that matches. Now this is where it gets a little more advanced. I'm going to go ahead and graph this line and these points. So I've got a point a, f of a, and then I've got a point a plus h, f of a plus h, and those are showing up as green and purple dots there. It will actually let me slide those, but I don't want to really do that for now because I need to check my work for my problem here. So go from 2 to 7 again, or 2 to 5 again with the distance of h. And now I have the slope of the line in between. I'll use an m for that. Is going to be the fraction f of a plus h minus f of a over h, slope of 2. And my y-intercept, if you want to figure this one out, I'm going to leave that up to you. It's a quick problem with some algebra. If you kind of know your steps. So this is what I got when I worked it out. Basically, I just started with y equals mx plus b, fill in what I knew, and solve for what I didn't. All right, so there's that line connecting the points. One thing you can do is you can change, colors and things like that. I might just change all of those to match. We've got black points, and let's go with a dotted black line there. Now, what we've got is a line that goes from one point to the next. I can kind of slide it around. I could set my initial point first if you want, and then set the h, and it will automatically spit out that slope. So let's go back to -2, and h of 7. We got a 2 there. Does that make sense based on the answer we got? So 4 times -2 is -8 plus 14 is going to be a 6 minus 4 is 2. You can try it with something different. Let's say we wanted to just find the slope at this specific point. So basically we want to shrink h down as small as we can. Well, if I make h 0, it's undefined. I can't divide by 0. But what I can do is get very, very, very close. So I'm zooming in and in and in. And now let's just set that h at a tiny, tiny value. When the h value is that small, the slope is pretty much -12. So if we go back here, -2 times 4 is -8. If I make h 0, that term drops away, and it's -8 minus 4 is -12. That's going to be the instantaneous rate of change, and that's something that we'll do in calculus.